Dito yung nasa niya.
Give me number.
Good night, guys. How are we doing tonight? Hello. How are we doing tonight? Hello. Good night.
Good night, sir.
How are we doing?
As for me, I'm not so hot tonight, but I'm here.
Come to you.
I don't know.
Right. So I gather that some some bug is going around. Um, I have been hearing about and seeing and people with when having the sniffles. So um, just just be careful. Make sure you're taking the vitamin C, guys.
I'm not
And
sure
as
when is the bug, but I know I'm just extremely tired.
yeah, and I I talk about bug. Get me take my vitamin C because I was around some people today who were having the sniffles. Right. Um, all right, so we're on differentiation. My question to you is how comfortable are you feeling with the differentiation? There are so many more areas of differentiation that I want to do, but I just need to take a break from it because there is an area that must come. Now, you know what you call talkie, what a topic here, other than to tell us, say, it is a staple on the exam paper and it must come. So all I'm going to say to you that because it must come, you must learn it. You must learn it. It is going to, yeah, same thing too. And I should pause, Oliver, how you feel, Papa? It's a teacher start class and not even checking for you. How you feeling now?
No, man, but dep on the recovery road,
Nice, 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 nice. Happy to hear. Is there anybody that's not feeling well or everybody that's all right?
Just extremely tired, sir.
Yeah, man, trust me, talk truth. I just got in. Well, not got just got in. I got in before 7, but I've still not yet changed. I just sat down and just lounging and just waiting to start the class, and then the computer shut down on me, and then I had to reboot. So, so that's why it took me a little while to even get in. But yeah. So I'm saying to you that I'm going to present something to you tonight. I'm going to start it. I won't finish it. I'm going to start it tonight. But what is important is for me to start it, you have to understand it. It is not a ask, it is a told. I'm not asking you to understand it. I'm telling you that you must understand it. It comes as a full question. Sometimes it comes, your questions this time is going to be 30 marks because you're going to answer 2 questions for 30 marks each. The question can come for 20 marks. Easy, easy. No, if you get a question for 20 marks, then you shell it. And if you can't even do not more in that question there, that's a 66% to get on a one question there. So I'm telling you, on a must learn it. So what I'm gonna do, I'm gonna I'm gonna copy, I prepare something for you. So I'm gonna copy the slide that I want to work with now, send off to you into your personal WhatsApp space, and then I'm going to put us back. We're gonna go through it and we're gonna go through it slowly. Now, what we don't finish tonight, I'm gonna ask that you go through it and do the rest of it for your preparations. I will have to run out for maybe about 10, 15 minutes to do something, but give me 3 minutes to send you all what it is that I prepared for you, and then we need to go through it. if you understand this one question, 3-page document that I'm going to send to you now, you're going to be good to go. It means, and that's why I'm breaking the differentiation. You have enough differentiation in you for me to teach you this topic. You have enough differentiation in you to finish this topic. The questions on differentiation that you get will not come up to 20 marks in full. So I must break from my differentiation to teach you this topic. So I don't finish differentiation yet, but I have to break in order to teach you this topic. And I'm saying to you, I'm not asking. It's not an ask, it's a told. You must understand this topic. So give me 3 minutes and I'll come back to you. All right, guys, can you check to see if you received um uh, a WhatsApp from me, please? I'm having some issues. The system not going through as quickly as I'm hoping. Can you just double check for me, please, to see that you received a WhatsApp message from me, some applications to differentiation?
Received.
All right. I'm gonna ask somebody to share it for me, please. And
Ask someone
to share screen because I have to run out for a few minutes. I don't want to share screen. So I send it off. So I'm just gonna ask somebody to share screen and I'm gonna go through the first part of it with you, explain it, and then I give you one question. Now, I gather that people not so relish, don't want to make it a habit, but once I can go through this, we just call it an evening. But on Thursday, God's willing, we're starting at 7 o'clock. But now wait until 7:15. We're starting at 7 o'clock. And we're gonna run it right through until 10. So we can make up for some lost times. So once you start sharing, I'll go through it. Thank you. So am I to understand that nobody's going to share the screen for me? Don't do this to me tonight, please. Oh, thank you. Appreciate it. All right. So this is an application question, an application to differentiation. It's an application question and it's application to differentiation. Thanks for sharing. Now, as I explained to you before, f of x is equals to y. If I'm using the convention f of x when I'm differentiating, I'm going to have f dash of x. And f dash of x is suggesting my first differentiation. Or I can say my first derivative. If I'm using y, my first differentiation or first derivative is dy by dx. My first differentiation or first derivative is dy by dx. if I'm using a convention f of x, my second differential is going to be f double dash of x. And if I'm using a second derivative, using y, it's going to be d squared y by dx squared. So that's what I try to explain to you there. I'm trying for my notes to be self-explanatory. So that's why I go as far as putting it in red, just to highlight the fact. So whichever convention is used, you should be okay with it. I could give you g of x, and if I give a g of x, it will be g dash of x, g double dash of x, and so forth and so on. All right? Now, when I'm differentiating to find the stationary point, when I'm trying to determine the stationary point, I'm going to differentiate the function. I'm going to differentiate the function. Having differentiated the function, my next step is to set the differential equal to 0. My next step is to set the differential equal to 0. My next step is to set the differential equal to 0. And then I'm going to solve for the unknown. What this gives me is or are the critical values, value or values. Sometimes I can have a critical value depending on what the function is. If it's a linear function, if it's a quadratic function, I'm going to get critical values. If it's a cubic function, I'll have critical values. All right? Then I'm going to substitute the critical values into the original function f of x from part 1. And then the result together will yield my stationary point, my critical point, or my turning point. All of them mean the same thing. So sometimes you may hear me ask you to find the critical point. Then the other question I ask you to find the turning point. Then the other question I ask you to find the stationary point. I'm asking to calculate the same thing. That one something have 3 different names. I call it stationary point, I call it turning point, and I can call it critical point. They all mean the same thing and can be used interchangeably. And my stationary point is a coordinate written in the x, y form. Written in the x, y form. What is the x, y? That's a coordinate form. So there are 4 steps to determine the stationary point. 4 steps to determine the stationary point. Step number 1, first thing, to differentiate the function. Second thing, set the differential equals to 0. Third thing, we're going to substitute, set it equals to 0 and solve for the values of x, value or values of x. The third thing is that we're going to substitute that critical value or those critical values into the original function to obtain the other part of the critical value, which would be my y values. And then when I put the 2 of them together, then I get my stationary point. Sir, I hear you, but I don't follow. Not a problem. Can you scroll up for me, please, for example number 1? All right. So it says, come on, Papa. It says, given that the function y is equal to x squared minus 6x plus 1, determine the critical point. That's what we're looking at now. So we're trying to find the critical point. So it says to determine the critical point is what I'm trying to find. All right? Remember, I just gave you 4 things. Thing number 1, you're going to differentiate the function. Then we're going to set the differential equals to 0 and then solve for the value or values of x. Then that value or those values of x, you're going to substitute into the original function to get out the y value. And then you put the x value and the y value together to give you your stationary point or your critical point, or better yet, your turning point. All right? So scroll up for me now. Y is equal to x squared minus 6x plus 1. So the solution is to differentiate the function. So I'm going to differentiate. I'm given y equals x squared plus 6x minus plus 1. When I differentiate that function, scroll up for me, please. When I differentiate the function, I'm going to get 2x minus 6. Do you agree with that? Do you agree with that? Answer me, guys.
Yes.
Yeah, man. So when I differentiate, that's what I'm going to get. 2x minus 6. No, man. Scroll up for me, please. 2x minus 6. Now, that is my differential. That is my dy by dx. Now, what the method says, when I differentiate it correctly, then I'm going to set my differential equals to 0. Right. So I'm going to set 2x minus 6 equals 0, which is what I have there. And then I'm going to solve for the value of x. So what I'm going to do is to add 6 to both sides. So I'm going to get 2x is equals to 6. Can you see that?
Yes.
Mm-hmm. And then I'm going to solve for the value of x now. If 2x equals 6, that means x equals 3. Talk true.
Yeah, okay, divide 2 by 2.
Very good. But you recognize that this one gives me only one value of x. So I only have one critical value. In order to find the other part of it, I now have to substitute x equals 3 into the original function y. And remember, y is equal to x squared minus 6x plus 6.
Plus 1.
Plus 1. Thank you. I just said that there to see if you're paying attention or who was paying attention. Thank you, Pops. If I have some notes to the side, I'm not going to talk about those yet. I may do that next class. We're going to leave that piece alone. We're just going to look at the left-hand side. Scroll up for me, please. Let me show you the substitution. Anywhere in y equals x squared minus 6x plus 1, I'm going to put in 3. Come on, continue scrolling. Continue. Continue. All right, so you see what it is there? I am now substituting. And anywhere in the function I see x, I put 3. So it now becomes 3 squared minus 6 times 3 plus 1. 3 squares is equal to 9. Minus 6 times 3 is equal to 18, negative 18, plus 1. 9 minus 18 is negative 9. Negative 9 plus 1 is going to be negative 8. Scroll up to see if you get y equals negative 8 for me, please. Yes, no?
Yes.
Good. So now I'm going to put them together. Remember, x is 3. So because I'm writing it as an ordered pair, an ordered pair is written as x comma y. An ordered pair is written as x comma y. So my x value, I'm going to write it as 3 comma negative 8. So my critical point is going to be 3 comma negative 8. Scroll up and look and see if you're seeing that for me, please.
Yes, sir.
All right, good job. So that's my critical point. So this particular question has one critical point. Now, the truth of the matter is, the ones that we're going to give in the exam, we're going to have 2 critical points. But this one is just way too easy for 20 marks. So I have an example 2 there that I'm going to ask you to work for me when I'm running out. But this is it. To find the critical point, you differentiate the function, you set it equals to 0, you solve for the value or values of x. When you catch them, the one there or that one, you're going to substitute that or those into the original function. And whatever value or values you get out would be your y value. And then you put the x, comma, y. You put the x value first, comma, and then the y value. So the x value in this case is 3. And we just calculated the y value here to be -8. So we're going to put 3, comma, -8. So that is my critical point. Scroll up and see if you see something that says critical point is 3, comma, -8. No, not that up. Down. Sorry, I keep saying up. Yeah, I want to go to right. See, no, going too far. Right. See there? So critical point is 3, comma, -8. All right. Now I'm going to ask you to scroll up. Let's just go back to the top of the document. So I just showed you how to do the critical point. Go back to the top of the document and it says, right, it says to classify the nature of the stationary point. You remember stationary point is the same thing as critical point, same thing as turning point. Scroll for me, please. So it says, there's a graphical method that I have in question 2. In example 2 that I wrote. But I'm not going to look at the graphical method just yet. So to determine the intercept, in order to find the x-intercept, you're going to put y equals 0 every single time. To find the x-intercept, it is the opposite one we put in equals to 0. So I cannot ask you to find the x-intercept, I'm going to put x equals 0. That don't work. So once I said find the x-intercept, it means then that what I want you to do is to put y equals 0. I'm going to ask you to find the y-intercept, you're going to put x equals 0. So when I ask you to find the intercepts, you're going to say which of them, sir? And if I say the x-intercept, look another function where you say y you put equals to 0 because the opposite one that you put equals to 0, and then you work it out to get that intercept. And if I ask you to find the y-intercept, then anywhere in the function you see x, you put 0, you work it out, and that's a value. All right. The intercepts is just where it, as it says, intersect. It's where the graph intercepts your values, your Cartesian plane, your x-axis and your y-axis. All right. So go down for me now, please, to the question. It says to find the coordinate of the y-intercept. To find the coordinate of the y-intercept. So since I'm asked to find the y-intercept, what do I do?
X to 0.
Very good. So anywhere in the function I see x, I put to 0. So remember the function is y squared minus 6x plus 1. Y squared is equal to x squared minus 6x plus 1. So that is going to be 0 squared minus 6 times 0 plus 1. So that means y is equal to 1. X equals 0 and y equals 1. Scroll down for me, please. Let me see the solution today. Oh, yeah. It's there already. Thanks. So the coordinate of the y-intercept is going to be 0, 1. Why 0, sir? Because I'm finding the y-intercept. It means that x has a 0 value. X has a 0 value. Because anywhere in the function I see x, I put in 0. And then my y value is going to be the result of that. And in this case, my y value is going to be 1. Put it this way. It is possible that the y-intercept can be 0, 0. It is possible that you can have the y-intercept. When you work it out, you get 0, 0. Or better yet, 0, 0.
Pass through the
Origin.
yes.
Right. So when it is 0, 0, it passes through the origin. Am I clear so far? Am I clear so far?
Crystal Lee.
All right, good job. I don't hear the others asking, Mr. Simon, I'm not sure you're talking to me, you know.
Just reaching, sir.
All right, cool. All right. It then asks if the point is a minimum or a maximum. In this your case, to check if it's a maximum or minimum, you're going to find the second derivative. It means that we're going to differentiate the function one more time. We're finding the second derivative. So you see, you remember, recall dy by dx is equals to 2x minus 6. dy by dx is equals to 2x minus 6. So what is going to happen? I'm going to differentiate the function again. So it means that I'm going to have d squared y by dx squared. And that's the notation. The notation d squared y by dx squared is to indicate that I'm finding the second derivative. The first derivative is denoted dy by dx. The first derivative is indicated by writing dy by dx. The second derivative is going to be indicated by writing d squared y by dx squared. All right. Now, when I differentiate that function one more time, I'm going to get x equals 2 because the differential of negative 6 is 0. And when I differentiate 2x, I get 2. So what I'm going to do, what should happen is that my critical point, I'm going to be substituting into the second derivative. But you recognize in this case, the second derivative is a constant. So there is no substitution. The one that you're going to do on your own will have a substitution. The one that you're going to do on your own will have a substitution. So because it is positive, we're going to have a minimum. Because it is positive, we're going to have a minimum. Because it is positive, we're going to have a minimum. Because it's positive, we're going to be having a minimum. If it is negative, we have a maximum. I want you to write that down somewhere into your head. Positive, you're going to have a minimum. Negative, you have a maximum. Positive, minimum. Negative, maximum. Positive, minimum. Negative, maximum. All right? So the second derivative, when I calculated the second derivative, I got a whole number. So I'm unable to substitute my critical point or my stationary point or my turning point into.
Small restroom break.
All right, cool. Into the second derivative. But in the one that you are going to be doing, you will get an opportunity to do a substitution. Now, because the second derivative is positive, and there is no variable for which to make a substitution, we are going to just use that as our final answer. It is positive, so we have a relative minimum. We have a relative minimum. Had it been negative, we would have had a relative maximum. A relative maximum. And based on that, I think that will be the end of the question. Is there anything else? He's not here just now to scroll. Right. That I think that should be it. I think there's a part 4 to. Is there a part 4 to the question talking about sketching the graph, or that's a part 5?
Sir, there's a part four for the sketch.
Right. There's a part 4 for the sketch. I'm going to hold the sketch for now. And then what I'm going to ask you to do, and for those of you who are just coming, I need to run out to do something for someone. I just need to drop someone. I can't tell you. I'm going to drop someone down the road. I gave a lift and the person is here with me. So give me about 15 minutes, but I will still be connected. Good thing to know that you are sharing the document for me on screen so I can navigate easily. What I want you to do for me is to attempt that example 2. We're not going to go through the sketch just yet. When I get back, I can look at the sketch.
All right, sir.
Sorry about that. Right. So there's a second question. This one talks about point of inflection, but I will direct you on that fourth part, which is I was asking if there's a 4 and a 5. But I'll direct you in that. No, let me tell you a secret. Is it the same way example 2 set up? Expect the exam question to set up in the exact way. Let me say it slower. Example 2 is a perfect example. It's not the same question, you know. What I expect for the exam is that they're going to ask you the same thing. Critical points, coordinates of the y-intercept, determine it's a maximum or minimum, determine the point of inflection, sketch the graph, showing all the points. The only thing that is going to be different from this question to the question that you're going to be doing in a couple of weeks is going to be the function. I promise you, if you look at the past papers, you can see that I'm speaking the truth. I want you to pay special attention. All right? I will walk you through the point of inflection. What I'm going to ask you to do for me now is 1, 2, and 3. That's what I went through with you. I show you back by that time. However, if you have a question, you can talk to me because I'm not leaving the class. All right? So on your mark, get set, go. If you have a question, you still can talk to me. All right? And I'll talk to you as during the journey. Thank you. Have you started, guys?
Yes, sir.
All right, good job. I'm here. I'm in commute now, but just go on work. All right, cool. How is it going, guys? Are you okay? Any difficulty with the differentiation? Can somebody tell me what they got for the differentiation, please? Well, sorry, not that. It says to calculate the coordinates of the y-intercept. To calculate the y-intercept, what do we do?
X equals zero.
X to 0.
You put x equals 0. Very good. And when x is equals to 0, what's the value of y?
Constant.
Huh?
Constant, sorry, -7.
-7. So give me the coordinate of the y-intercept now. What's the coordinate of the y-intercept?
0, -7.
0, -7. Very good. So it's 0, -7. All right. Now, so that's very good. So you get some points for doing that. Just remember, if you follow the instructions, you should be good to go. All right. Have you differentiated the function?
No, sir.
Have you differentiated the function? No, yeah?
No, sir, I didn't. Don't start
All right.
it at last start.
All right. Okay, go on do it then. I'll wait on you. you guys have done the differentiation yet? Let me hear what the differentiation sounds like. Night. What does the differentiation sound like? Nobody don't differentiate it yet?
Sir,
Uh-huh.
then 6x squared plus 6x minus 12.
Very good. Now that is what you're going to be setting equals to 0 and solve. So what you're going to end up doing is to factorize. You're going to have 6x squared plus 6x minus 12 equals 0. And you're going to factorize that one for me now. Anybody remember the factorization? How to do factorization?
And
Say it again? No? I want you to make an attempt in factorizing that question for me. You're going to look at the coefficient of x squared, and you're going to be multiplying it by the constant. You're trying to find numbers when you do your calculation to get your two factors. So give an attempt on that and let me know what it is. If not, I will come in and help you. But let me see how best you can try it. 2 minutes. Any luck with the factorization, guys? Let me know so I can project.
so the same 12 and 6 minus also.
All right, then soon come. All right. So right, and so now, all right, so yeah, chef, it's when you sneaking in the eye class, I want to clear your throat, me know say it about in the bedroom. Because your teacher go through woolly pass up my never there earlier. And all
So
right, I'm gonna
this
ask.
is correct, you know, sir.
Huh?
X equal 1, x equal -2. That's correct.
X equal 1, x equal -2.
Hold on, this. It's not the answer.
What you say no?
You know, say that the answer. We wait until I go through.
What you say go for your answer? X equal 1 and x
Yeah,
equal what?
-2.
Ah, very good. Proud of your pops. Even though you just slide into the class and not yell up teacher, but very good. Very nice. Everybody see how chef gets the x equal 1 and x equal -2?
Yes.
Okay, so you got that, Oliver, right? Dre, can you unmute for me, please?
Yes, sir.
The whole of tonight, you don't say one word to me. What go on?
Okay. Nothing from here.
Hmm?
I'm here, sir. I'm here. I got the one. I'm working to get the -2.
Are you following what is an injury?
For this class, yes, I need to go back and double check the recording for the classes that I'm in.
Mm-mm. I'm not talking about tonight. Are you following what it is that I'm doing for this topic?
Yes, so far, sir, yeah.
Okay. Simon, thank you. Simon, what you say?
Sir.
Okay.
Sir, I got for the first one -1, but I'm trying to work out the second one, but I keep getting -18. So
It's not supposed to be -1, you know. Um,
sir, it's probably because I group the like terms together.
All right, stop sharing for me, please. Let me just and thanks for sharing the screen. Let me share my screen now and show you how to just refresh your memory how to go about the calculation. Well appreciate it. You sharing for me, Oliver. Thanks again, pops. Share screen. All right. So everybody would have seen the 0, comma -7. Um, to, to evaluate the critical point, as we told you, one of the things we do is when I differentiate the function. When differentiating the function. When we differentiate the function, we can get 2x cubed. When we differentiate 2x cubed plus 3x squared minus 12x minus 7, what we're going to get is 6x squared plus 6x minus 12. 6x squared plus 6x minus 12. I have an option there. And the option that I have is to divide through by 6. Why, sir? Because 6 is common. It's a common factor, and I'm allowed to divide through by that common factor. What's the difference, sir? Thanks for asking. It makes my calculation somewhat easier. It makes my calculation easier. But sometimes you get the question where it is that you can't divide through by nothing at all. You just can't divide through by nothing. I just so it's set. And if we go work it, so. But in this here case, 6 is common to each term of the equation. 6 is common to each term of the equation. Sir, equation, yeah, man. You remember you have to set it equals to 0. So you just turn the expression into an equation. So 6 is common. So I'm dividing through by 6 in order to simplify my function. In order to simplify my function. So when I divide through by 6, I'm going to get x squared plus x minus 2. So do I have to do it like that? I doubt Chevy did it. Chevy, did you divide through by 6?
No.
Right. I doubt you would have. But you ended up getting the same answer as I did. So the question is, sir, do I have to? No, you don't have to. But it's just that when you try to find the factors, you get bigger numbers. But if you can work with those numbers, that's fine. Perfectly fine. All right? So this is, if you look at the screen, it says recall. To factorize the trinomial above, we're going to multiply the coefficient of x squared, which is the number in front of x squared, which is a 1, by the constant, the one that stands alone, which is -2. So we multiply those two numbers. 1 times -2 is -2. Now here what happens. I now need two numbers. When multiplied together, will give me -2, but when added will give me the middle number, which is +1. I need two numbers. When multiplied together, that gives me -2. That is a 1 from the coefficient of x squared by the -2, the constant. I need two numbers when multiplied together will give me -2. But when added, it's going to give me a +1. Those two numbers are +2 and -1. So what I'm doing is this 1x in blue, that 1x up top there in blue, I'm breaking up into this 2x minus 1x. 2x minus 1x gives me this middle term as +1x. So I'm breaking it up. And when I break it up, I know end up with 4 terms. You recognize I had 3 terms? 1, 2, 3. Here, I now have 4 terms. 1, 2, 3, 4. So technically, I split the middle term into 2 terms. But in order to split it, you have to go through a particular method. There's only one way you can split it. Multiply the coefficient of x squared by the constant, and by trial and error, you figure out the middle term, the 2 numbers. Only one pair of numbers will ever work with these questions that are factorizable. Only one pair of numbers will ever work with these questions on factorization. So I'm in a group. I'm in a group, I'm putting the first 2 in parentheses, then the next 2 in parentheses. So does it matter if I put the 1x, the negative 1x before the 2x? It really doesn't matter. Tomato, tomato. Really doesn't matter. So I've decided to put these 2 in parentheses, x squared plus 2x in parentheses. Leave out my middle sign every time. Your middle sign will be left out every single time. And then I'm going to group the last 2 in parentheses. But you have to be careful that once this middle sign here is a negative sign, the last sign here is going to be flipped. So the middle sign here is a positive, is a negative. This negative 2 will have to be split into a positive 2. It will have to be split into a positive 2. Have to be split into a positive 2. Why, sir? Again, thank you very much for asking. It is done so because when I'm distributing that negative 1, say negative 1 that is outside in the parentheses, negative 1 times this x gives me a negative 1x. And this negative 1 times this 2 gives me a negative 2. So I get back what it is that I have. Also, you have to be minded that whatsoever sign in one parenthesis has to be the same side in the other parentheses. Both signs must, both signs must be equal. Both signs must be equal. And when that is done, I'm going to factorize. What is common between x squared and x? And your answer should be x. What is left? What do I multiply by x to give me x squared? It has to be another x. It has to be another x. What do I multiply by x to give me 2x? It has to be 2. I'm finished with that first parentheses. This negative sign here is really a negative 1. So I'm now putting in my negative 1 there because I'm doing the multiplication. Negative 1 times what is common between here and here is just 1. So I'm going to have x plus 2. So I write out my x plus 2 to be the same thing. What is common to you? You. Somebody else may have something, but you're always common to yourself. That's why 1 is not a prime number. Because a prime number has 2 factors, itself and 1. And 1 is 1. But it must have 2 separate factors. Itself is 1. and a factor of 1 is 1. But the two one are the same one. So that's why 1 is not a prime number. 2 is a prime number. Because the factors of 2 are 2 and 1. Two different numbers. So yes, it's going to be called a prime. The only even number that is a prime number is 2. Any questions?
Not so far.
Huh? Not so far. Okay. All right. Go binding down. So now, what is common between all of this here and all of that there? And I would hope that you see that the x plus 2 is the same thing. So I factor out the x plus 2. When I take out x plus 2 from here, what I have left? This x. And see it here, boom. When I take out the x plus 2 from here, what do I have left? This positive 1, negative 1. See it right here, so negative 1. And of course, I made it the expression now an equation. So for each step, I have to write my equal 0. Real talk. No, either this x plus 2 equals 0, which implies x is equal to negative 2. And similarly, x minus 1 equals 0, which implies x equals 1. So yes, Chevy, you are correct. You are correct because when I did my calculation, I got my x equals 1 and my y equals negative 2. Now, Chev did his question differently from how I did mine. Did we end up with the same result? Hello, somebody? Is Gomel going to sleep?
Man, I didn't hear you, sir.
Say it again.
Yeah, man.
All right. So I'm saying that these are known as my critical values, and we now need to substitute them into the original function. Always remember it's the original function to obtain the corresponding y values to give you the critical point. Remember, it is the original function that you're substituting, you're back substituting in. It's the original function, not the differential function, the original function. So anywhere in the original function, I see x, I'm going to put negative 2. And anywhere in the original function, I see x, I'm going to put positive 1. I'm substituting my critical value, critical x values, into the function, the original function at that, to get my y coordinate. So anywhere in 2x cubed plus 3x squared minus 12x minus 7, I see x. I'm going to substitute negative 2. And negative 2 cubes is going to be negative 8. And negative 2 squares is going to be equal to positive 4. And 12 times negative 2 is going to be that. And when I evaluate this, I'm going to get 13. You can go ahead and try that calculation for me. I'm going to send you this. But you can go ahead and try that calculation for me. I'm going to have y equals 13. So my critical point now becomes this x. Remember, you write the coordinates as x comma y. So this x has negative 2 and the y has 13. See it right here, sir? Negative 2 comma 13. Pausing there for 2 seconds. What to be now? You good? I can move? As I told you before, The aim is not to finish this topic tonight, you know. I just want to whet your appetite enough that you can leave and go and have something to do. Hello.
It's good fun, yeah. So say, oh, so I lost 2 critical points.
Right. So I just put in x equals -2. When I put in x equals -1, I'm going to get the other critical point as 1, -14. When I complete my substitution. Have you seen that? Is 1, -14?
Yes.
Mm-hmm. And that's where we find the critical points. That's where we find the critical points. Hello, can I go? I just need about 2 more minutes with you. Watch this. We're going to look at the nature of the turning points. We're going to look at, matter of fact, I'm not going to start this. I'm not going to start that. I'm going to send it, but I'm not going to start it. Are there any questions relating to what is up top? Hello, somebody? Wanna go and left me, no? Wanna go and left me?
No, man, there, man.
No, you there, but the rest of them are there.
Sir, I'm here. I'm just up and about. Sorry.
Okay. All right, I'm gonna stop here for tonight. And trust that what it is that I have done and that I'm sending to you, you'll get an opportunity to go through it along with the record. Remember, this is a must-have. You must get one of these questions. I can't tell what the function is going to be, but you will get on the question. You will get one. Real talk, no questioning, you will get one. So I'm going to urge you to go through.
I take a look at break, move forward.
Say it again.
I take a restroom break, just a
Oh,
moment.
okay, yeah, man, sure. It's very important that you go through and try to commit what we're doing here to long-term memory. What I have just done is to send you the updated version of what it is that we just did. You guys sound tired? Pick up yourselves and do some work, and let us continue this conversation on Thursday, God's willing. All right?
Yes, sir.
All right.
Listen. You man, take care.
Night, sir. Night,
Bye
everyone.
bye. Yeah, man.
Okay.
You're gonna have popcorn.